What would you do if a disaster strikes and people desperately need help? We send a rescue vehicle. Our group was tasked to design an all-terrain robot to aid in disaster relief. It needs to be capable of adapting to all situations, traversing over rubble, surmounting large obstacles, and ensuring a safe stopping distance where necessary. We shall test its ability with a simulated obstacle course. On top of this, the robot needs to be friendly looking to reassure victims that help is on the way. We named our vehicle the Crisis Rescue and Patrol Rover, or CREPR for short. We drew up 5 possible designs and eventually chose Design 1 as shown. Design 2 was a 4-wheeled truck with square protrusion wheels. While this may help increase the grip, it will likely build up dirt. Design 3 was a track vehicle powered by 4 wheels. However, we believe that in uneven terrains, the tracks may easily dislodge. Also, the long tracks would increase the turning radius of the rover, making it less maneuverable. Hence, we moved on from that idea. Design 4 was modelled after the British Mk1 tank, but along with the limitations of the previous design, this design would additionally be prone to pitching forward due to slope tracks. Design 5 was to use 4 pinwheel-shaped wheels on our robot vehicle. Although it was interesting, it was not rational. We concluded that it would result in poor stability, poor grip, and low durability due to uneven diameter across the wheel. After reviewing all 5 possible designs, we chose Design 1, a 4-wheeled vehicle highly capable of traversing across uneven terrain in disaster zones that has unrivaled stability, durability, and good traction. Our first chassis was made out of cardboard to test if the proposed design was durable enough to hold the components and endure the stresses while clearing the experimental obstacle course. We also tested the Arduino circuit with the attachment of the motors and the ultrasonic sensor to see if they were working fine. We concluded that the vehicle's frame had to be sturdier, the wheels needed more grip, and the clearance height between the vehicle's base and the ground had to be increased. In our second prototype, we decided to use yellow corrugated cardboard to strengthen the vehicle's chassis. Our new A-frame base design also helped to increase ground clearance. We had also used geared DC motors and plastic wheels in place of cardboard wheels powered by micro servos. Although the rover had greater success in traversing the obstacles owing to the better grip on the wheels, we found that the vehicle's frame was still too flimsy and the chassis was too small, leading to poor cable management. We also decided that the wheels still needed to be bigger. We upgraded the frame to include more sturdier components and we implemented the following. Firstly, we reinforced the structure with metal strips. Secondly, we wrapped the wheels with anti-slip mats to increase their diameter and provide more traction. Thirdly, we secured the motors to the frame using acrylic joints. We used a power bank and a 6-volt battery pack to power the vehicle. However, the vehicle's weight was imbalanced as the Arduino and the breadboard components were not securely placed. This made the vehicle inconsistent in its ability to clear the obstacle course. The vehicle also lacked user-friendly features which we felt would be helpful to the operators while rescuing disaster victims. In our final prototype, we created an additional platform to house the power source, Arduino, breadboard, and other components. The platform included a power bank compartment and holes for motor wires to pass through. We also focused on the user-friendliness of the rover. We made an exterior shell for our vehicle featuring a red cross, which universally represents aid and relief. This would give distressed victims assurance. First, we installed LED lights at the front of the vehicle to improve its visibility to disaster victims and operators alike. To make the rover easy for operators to control, we implemented an on-off switch. Next, we introduced a flag that will wave upon discovery of a victim to signal that help has arrived. To improve our design's versatility, we increased the power-to-weight ratio by placing 2 9-volt batteries in parallel, accompanied with a 5-volt power bank in place of the original 4 1.5-volt AA batteries. This allows for greater payload. The vehicle had successfully cleared the experimental obstacles and met the criteria given to us. We are ready to take this to the next level and create a life-size prototype. We have the confidence that our vehicle will be of great assistance to the disaster sites and save many lives. One day, a CREPR might even save you.